It is a very big story of the story is very big for a transport layer. So we'll try to make it as a little less. Okay, so transport layer. Guys, can you able to hear? I'm muted or not muted?
Yes.
So transport layer. What is this transport layer will do? From here, a lot of things will be changes. So we'll see that one. The transport layer is segment the data. Segmenting. Okay. What is segmenting? Chop data into small pieces. Small pieces. So cut the data into small pieces or chop the data into small pieces. Anything you can use word cut or things. So what is a small piece of data? Small data are very easy to transfer. For example, easy to carry, easy to transfer kind of stuff. Nowadays we are buying online so many things. Like you buy a cart, it's like a assembled cart you are getting, not direct cart. We can't transfer, so we can get this kind of stuff. Assembled parts means piece parts you will get it. Then you receive it and you can assemble it. So when you are sending a data, so then again. Look at here. I'm sending a data. So for example, my data is how are you? My regular example is hello, how are you? This is my data. Now I'm transmitting from here to here. Okay, I'm transmitting the data. Now what happened at receiving? It received like this. Meaning is something missing. Something missing. It means wrong data. As per the data you transferred at receiving end, it receives something, but it is damaged one. Then what to do? You send again. You send again. Again you are sending. Okay. This time it received like this. Like this only. Because of lot of disturbance in the network, right? So you are sending and packet, lot of collisions will occur. There's a possibility of data damage. Right? So every time there is a part of data is missing, so obviously data error is occurs. Remote system drop the packet. Remote system, what it will do? It drop the packet. It is wrong. It is wrong. It is wrong. Like that. What it will do? It will drop the packet. So what we have to do it again? You have to send it again. You have to send it. So most of the time you are only sending it, but you are not receiving it. So that is here. Okay. So what I'm going to do is I'll chop this data. I'll cut this data into small pieces. And what I will do it, I'll put some numbering on it. For example, I put a numbering like this: 1 by 2, sorry, 1 by 4, 2 by 4, 3 by 4, 4 by 4. So I divide the data into 4 parts and put some number, for example only. Okay, I'm sending this data now like this. First I send a first packet. Client received the first packet. This is a C1, sorry, C2. This is a destination. This is source and destination. First I send a packet 1. So hello is received. Second packet I send. Third packet I send. Fourth packet is sent. For example, this system received first 2 and 4 only. Third is not received. In generally, when you are communicating, what will happen? So when destination received, it send an acknowledgement. So I received acknowledgement 1. I received a acknowledgement 2. I received a acknowledgement 4. Okay. So the third packet is not received. It doesn't send any acknowledgement. So my source machine understand first packet, second packet, third, fourth packet is delivered successful. Third is not. What it will do? It send a third packet again. So whenever the destination received, it send a acknowledgement. Yes, third packet is received. Now see the order. See the order 1, 2, 4, 3. So how it is look like here? Receives. Hello, how you are, right? So it is the message become like this, but it will rearrange it back normally. Okay, so it will rearrange it normally. So where to put like this, I will put it. So why? Because of we have a numbering sequence is there. So then it will rearrange it in a proper order. Now what happened? Even though if there is a packet loss, no problem, we'll resend that packet. So then we can total message will be assembled at destination. So that is a main part of one part of the transport layer. That's why it is end-to-end connectivity. Segmenting, numbering, and sequencing. Hence the data. Segmenting, numbering, and sequencing. This is main part of transport layer. Of course, there is another part of transport layer. It is also there. There's so many are there. Let's see. You are communicating with a different type of protocols. Okay. So we are communicating with a different type of protocols. Okay. Like HTTP, FTP, like the different type of protocols. Okay. Here it is. Under type of protocols, say TCP and UDP type protocols are there. Okay, so in the protocols are divided into TCP type and UDP type protocols. Also you can write like this. In protocols we have TCP type and UDP type protocols. Okay, so TCP type protocols, UDP type protocols are there. So what are there? We'll see it. TCP type UDP. What is TCP? Anyone?
Transfer control protocol.
Transmission control
protocol.
UDP. User
Datagram Protocol.
Very good. User Datagram Protocol. Okay, so there is a small differences are there. Okay, it is a acknowledgement based protocol. Don't use acknowledgements. No acknowledgements here. So how it is? This is my source and destination. I send a packet. Just I told example, right? So same thing only. I set a packet, destination received. I send a packet, destination received. Then it will send an acknowledgement to me. Send a acknowledgement to me. Again, I'm sending a packet. Destination received a packet. What it will do once it is received? I receive a acknowledgement like a packet is delivered to destination. For example, I send a packet. Destination not received it. I didn't receive any acknowledgement. No acknowledgement. Okay. I send a packet. Packet is received. I'll receive acknowledgement for the packet. Right. Now what happened here? Third packet is I didn't receive any acknowledgement. So what I will do? Again, I can able to send a packet. If I receive a acknowledgement for that, means it is packet is received. Packet is received. So that is how TCP works. Acknowledgement based. Of course, there is a proper explanation is also there. Synchronization, no synchronization kind of stuff, read and write kind of stuff is there, but I'm not going to that point. Okay. I'm telling just only acknowledgement based only. In UDP, again, source, destination. Send a packet. Destination received a packet. I send a packet. Destination received a packet. I send a packet. Destination received a packet. I send a packet. Destination not received a packet. But I don't know. I don't know whether it is received or not. Just I'm sending a packet. I didn't verify the destination is really receiving a packet or not. Just for example, I don't know destination is received a packet or not. I'm not resending the packet. Either a destination got a packet, good. Not get a packet, we don't know. Okay, so like this. This is the acknowledgement based, no acknowledgement based protocol. That's why, because of this acknowledgement, TCP called as a connection oriented. Last time in one batch, the people are asked question. So UDP is a connectionless. Then how it is connected? Yes, it is not a physical connection. Connection oriented or connectionless. Okay, it is not a physical connection or a logical connection. The connection meaning is like the destination is received. For example, I take a class. So some classes of mine itself it is. I took a class. I will tell for 1 hour, half an hour, 1 hour, 2 hours, 3 hours. But other side, people don't give any response. You can ask them like, do you understand? Not understand? Do you have any doubts or anything? Nothing. No response. It's like a connectionless protocol. You went to your home late. Your father call you and start scolding. And what you do? Become a connectionless. You don't speak anything. Even your father don't know you are listening or not. You keep speaking. Okay, like that. You know, it's a connectionless. Means no two-way communication. We are sending, but we don't know other side received or not. That is a connectionless protocol. It does not mean wire connection, wireless connection, and all. You know, when I was in engineering and a lot of classes from outside also, people tell an example. Connection oriented means wired. Wire, you use a wire cable to connect a network, connection oriented. If you use a Wi-Fi, that is connectionless. That is also wrong. That is also wrong example. Okay, connection oriented is behavior of the protocol. Connection oriented or connectionless or TCP or UDP is a behavior of the protocol. Okay, certain protocols are TCP type of protocols. Connection oriented, it means when it is communicating, destination received a packet, then it will tell you I received a packet by using a acknowledgement. Connectionless, connectionless means destination don't tell you it received a packet or not. So that is a connectionless type of protocols. Okay, it is reliable protocol because we know we send a packet and other side it receive. So comparatively TCP, UDP is a faster. Okay, it is slower, faster. But it is not a matter. It is why slower and faster? Why? Because of acknowledgement based. So every time you should know the packet is delivered or not. So that's why it is. It take time to send a multiple packets. So then make sure that destination received. Otherwise, we'll send again. But in a UDP, it is not like that. You send it whether it is received or not. We don't mind about it. Here it is. Example protocols: HTTP, FTP, FTP, HTTP, FTP, SMTP, like this. These are the certain examples of a TCP/IP protocol type. Next, examples of a UDP: TFTP, TFTP, DHCP, DNS. Guys, not always. Every protocol should be under TCP or UDP. Sometimes certain protocols under TCP, certain protocols are UDP. So in this protocol things, some are TCP type, some are UDP type, some are both. Guys, understand TCP UDP difference?
Yes, sir.
Okay. So this is a transport layer, segmenting, numbering, and also type of protocols kind of stuff. Multiplex. And demultiplex. TCP UDP protocols. Multiplex and demultiplexing TCP UDP protocols. It is exactly say TCP type protocols encaps into TCP. UDP type protocol in communication, if I am using multiple type of protocols, right? So that encaps into UDP. That's just a data format kind of stuff. Transport layer also do flow control. Flow control. Okay, this flow control windowing. What is flow control and windowing kind of stuff? So when you are transmitting a data, from source to destination, okay, when you are transmitting a data, destination PC estimate destination how many packets can receive at a time. So like that. So my destination can receive 10 packets at a time. Okay, or per second. Okay, so it estimate that one and it will send it. For example, my destination receive only 5 packets. So my server send means my source send only 5 packets or 6 packets, not 10 or 20 packets. So depends upon the capacity of destination, you have to estimate. So if you want another example for that one also, I can try. Look at here. I have a connection. This is 1 Gbps network connection. It is 100 Mbps connection. So it can able to send multiple packets per second, but it cannot receive multiple packets per second. So first of all, source estimate destination capacity, based on that only it will send the packet. That is also done by your transport layer. I thought I will complete the entire OSI layer, but I'm not able to do it. Okay. The last part of transport layer I will tell, guys. What is that one? Packet unit. Packet data unit. In entire network, you have a saying a data is there, data is encrypted, data is uncompressed. But whatever it is, the data here we call it as a packet data unit. Packet data unit. Transport layer. Add TCP header to PDU. Means you have a different layers, right? So application layer data and then presentation layer, application layer, whatever the data is there, it converts into ASCII format, compressed and encrypted, and it is established session ID is there inside, right? And then different protocols we are using. Okay, then up to that one, it's a data is a PDU is not changing. Only thing is data format is changing. Data formatting. So whatever the data is there, it converts into ASCII format, compress and decompress and encrypt and decrypt will happen. Okay. Okay. So this is the only thing. So no data, additional data is not there, just data is there, but in a different format. But transport layer is not like that. Transport is a layer adding a TCP header to our PDU. So first part is header, like a TCP header plus PDU is called as a segment. So the segment sent to network layer. Okay, guys. So this is about your transport layer. Another two layers are there: network layer, data link layer, physical layer. Again, network layer. Yeah, we'll finish that one. So we have just 10 minutes. I'll put it. Tomorrow I will explain how layer wise troubleshooting. So I put a network layer. What is this network layer? Network layer having a route out protocols and routing protocols. What is this routed protocols or a IP address? Okay, IP address is logical address. IP address is also called as logical addressing. Okay, so two versions are there: IPv4. I'm not telling about IP address. Tomorrow I will tell IP address. Okay, if you want, you can go through my old videos also. If you have a time, you can go through my old videos also there. Just go for it. Not bash 13, I think. Go through bash 13. Simple, guys. Here it is, and open YouTube first of all. You can type my name. If you're already subscribed, it is there, but just type my name like this. So this is mine. Open it. Go to playlist. Okay, so go to playlist. So look at where more files are there in 15, 16. Where is 13? Yeah, here it is. In 13 also we have a networking related discussion is happened in 13. Of course, the service desk also we have it. Okay. Completely taken batch 2. Complete lot of practicals are there in a batch 2 also. So B2 2021. Next batch 13. So you can get a lot of information from it. Okay, so IPv4, IPv6 protocol, it is a logical addressing. So I'm not going much details. So tomorrow we'll go. Routing protocols. Routing protocols are a based on a best path selection. First path shows path to reach destination. This is routing protocols. Okay, so dynamic routing protocols are there under IGP. Interior gateway routing protocols, RIP version 2, AGRP, OSPF, and EGP, exterior gateway protocols, BGP. Yes. These are the network layer related one. Okay, routed protocols, routing protocols. But what network layer will do it? Add a source IP address and destination IP address to PDU. Now current PD is segment. So once it is done, this is also called as a PDU, the segment. Okay. So source IP plus destination IP address. This is as a one. This is the header. Header is this one, and you are having segment, right? Then totally we call it as a packet. The originally packet means this one only. Source IP, destination IP, and your segment related data. It is called a packet. The packet forward to data link layer. Data link layer having two layers again, LLC, MAC layer. LLC means logical link control. Better you can search once what is the LLC abbreviation. What is this logical link control? It has a WAN protocols or switch protocols. WAN protocols are like a SD, LC, PPP, frame relay, MP, LS, ATM. So WAN protocols, dealing with the WAN protocols, if in case you are communicating through WAN. And also support for a upper layer and bottom layer things. What is MAC, guys? Anyone? No one is telling? Okay. Media access control. How many bits? Represented in 12 hexa number. So example, you can take a 0 C colon pi E colon 66 0 F 01 0 B, like that example. So media access control, also called as physical address. So here what happened? Look at here. Add source MAC address and destination MAC address to packet means our PDU as header. Next, add CRC as tail. Heads and tails are there, like head, tail, tail or tailer. So look at here, source MAC address as destination MAC address plus your packet data unit plus CRC. This is a header. This is entirely network header. Network header. Next is called a tail or a tailer. Network tail. It also like that one. This is network header. This is data header. This is data tail. CRC, data tail. This is data header. What is CRC? Anyone remember CRC? CSC, cyclic redundancy check. Is nothing but an algorithm to check the data is good or corrupted. CRC is algorithm used to check it is 10 or check data is to prevent data from corruption. Okay. Or to check it. Also, it is used to check data is corrupted or not. Okay. Kind of algorithm it is. So yeah, of course, you know what is the resultant of this PDU? What is the resultant? It's called a frame. It's called a frame. Data link layer generate frame. Now in one or two batches got a question directly. What is the data output of a data link layer? What data link layer sent it to a physical layer? Frame.
01.
Very good. Yeah, physical layer is convert. It converts into bit stream. Yeah, you're telling that one only. Bit stream. What is bit stream? Binary coding directly, like a 0, 1. Like this. This is a bit stream. Not those here. It is a bit stream. Convert frame into bit stream. What is bit stream? It's a binary stream. Next, based on the physical device or NIC, based on your type of NIC use or connection, it converts into the signal. Okay, so for example, I'm using Ethernet. It is a copper type electrical signal. I'm using direct Ethernet type connection. NIC is a Ethernet type connection, wide connection. Okay, so for example, I'm using a Wi-Fi kind of stuff, wireless kind of stuff, radio waves. In case fiber channel I'm using, light wave, convert into light for transmitting media. So where is the bit stream? Physical layer. So this is your total layer, guys. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. The physical layer deals connectivity is physical connectivity, converts frame to bit stream or receive a bit stream. Okay, like that. So again, we'll go to top to bottom only. Application layer dealing with the services and applications. Okay, both server side and client side. It also understands the user request based on the protocols they use. Okay, understand the services. Protocols and port numbers are given. Why? Because of we use a protocol name, but actually computer send with the port number instead of protocol name. Okay, so protocols and port numbers are like this: HTTP, HTTPS, FTP, Telnet, SSH, RDP, SMTP, POP3, IMAP, DHCP, DNS, Kerberos, LDAP, NTP, SNMP, TFTP. Next layer is presentation layer. It encode the data, decode the data, compress the data, decompress the data, encrypt the data, de-encrypt the data. Whatever the data format it is, it convert into ASCII format. It compress the data, it encrypt the data. Okay, so prevent the data from anybody can access your data while you're transmitting, to encrypt the data. Session layer, it establishes a session, maintain the session, and terminate the session. Transport layer, it's segmenting the data, cut the data into small pieces, it put a numbering and sequencing. Also, it divide your protocols into TCP type into TCP box, UDP into UDP type boxes. TCP, UDP. TCP is Transmission Control Protocol, User Datagram Protocol. TCP is acknowledgement based, UDP no acknowledgement based. Okay, so in a TCP, when you are sending a data and a destination will send an acknowledgement, meaning is it is received your packet. Okay, if you don't receive a acknowledgement, meaning is destination not received your packet, so you have to resend it. That's why it is called connection oriented reliable network. UDP will send a packet whether destination received or not, the source don't know. That's why it is connectionless non-reliable network. There are some examples of TCP type protocols and UDP type of protocols. Okay, PDU means packet data unit. Everything we call this the data unit as a PDU. So from upper layers, we got a PDU. What are the data in the format? We add a TCP header to it. So obviously it become a segment. The TCP header contains segment numbers, protocols, like that. The structure will be there. The total we call it as a segment. Okay. Next, network layer. Network layer, add a source IP address and destination IP address to the segment, and it is become packet. Okay, the packet to the packet in a data link layer, it add a source MAC address and destination MAC address plus CRC as a data header and data tail. So this will become a frame. My PDU become a frame. CRC, cyclic redundancy check, it is to check data is good condition, corrupted, not corrupted kind of stuff. The physical layer convert this frame into bit stream, and based on your physical connectivity, it converts the bit stream into either electrical signal or radio waves or light waves based on the connectivity. So this is the your OSI layer. That's it. Okay, guys, understand or not at all understand? Any doubts? It's already 2:10.